This is a very simple but interesting question from the colligative properties. So the question is like this: for unimolar equimolar solutions, so the molality is same of acetic acid, dichloroacetic acid, and trichloroacetic acid. The depression in freezing point is maximum for. So let us write the equations, the formulas of acetic acid, the acids given. One is CH3, C double bond OH. Next one is dichloroacetic acid. So this will be CH, Cl, Cl, and C double bond OH. And next one is trichloroacetic acid. So that is Cl, 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 and C double bond OH. So these are the acids given. Now we know depression in freezing point, that is the delta TF. For a colligative property, delta TF is proportional to molarity. Delta TF is equal to Kf into M for simple solutions, and also delta TF is equal to I into Kf into M, where I is called as the Van Hoff factor. So what is Van Hoff factor? If the molecule associates or dissociates, the value of I will change. So that is the one of I, the value of I. Now, if you see, this is a dichloroacetic acid. If you take simple acetic acid, if it dissociates, it will be giving you H plus CH3 CO minus, meaning to say one molecule has been changed into two particles. Normally, in that case, your I value should be equal to 2. So here I value is almost the same for all. Now what is the problem here? We have to determine the depression in freezing point will be maximum for which acid. We know the acetic acid, the CH3 group is having, this is a weak acid, this is having a plus I effect. So this is having a plus I effect. So once it dissociates, it becomes the acetate, the acetate anion, which is a resonance stabilized one, COO, and there will be a negative charge here. So whenever I am going to increase the charge here by a plus I effect, its acidity will be less, or it will be less stable. So it will be least for acetic acid, and for dichloroacetic acid, you know that there is a minus I effect for chlorine. So that is going to enhance the acidity of dichloroacetic acid, whereas in trichloroacetic acid, since there are 3 chlorine, this will be having a maximum acidity, meaning to say you will be having a maximum acidity for this one. So acidity is maximum means the dissociation, whenever the acidity is maximum, the dissociation will be large. So dissociation will be large for trichloroacetic acid, for trichloro. So whenever the dissociation is large, your I value also is going to be large, and delta TF will be having a maximum value. Delta TF will be max for trichloro. So your right option will be trichloroacetic acid. But generally students will make, there is a common mistake, there is a trap going, it is a trap like question, because if the solution, since this is a dilute solution, if the solution is extremely dilute, what will happen? If the solution is extremely dilute, the acidity is not going to make any difference in that one. And so what is going to happen is, if it is extremely dilute, all the particles will be dissociating into 2. So if it is extremely dilute, already one is going to 2, the delta TF will be same for all acids. For all acids. But the condition is that it should be under only extremely dilute. If it is not extremely dilute, trichloroacetic acid will be having the maximum acidity. So you should keep in mind whether it has been written as extremely dilute. If it has been given as extremely dilute, the answer would have been the fourth option, the same for all.